A body moving in the positive x direction passes the origin at time t equals 0. Between t equals 0 and t equals 1 second, the body has a constant speed of 24 meters per second. At t equals 1 second, the body is given a constant acceleration of 6 meters per second squared in the negative x direction. The position x of the body at t equals 11 seconds is... Okay, so my approach here is actually to draw a little velocity versus time graph. So we're told that initially the body's moving in the positive x direction, and for the first second, between 0 and 1 second, maybe I'll draw this smaller, we'll call this 1 second, the body has a constant speed of 24 meters per second. So we'll call this 24, the units are meters per second, and maybe I'll just write units of seconds here. We can just write 1 there. So initially our graph looks like this for the first second. Next, at 1 second, the body is given a constant acceleration of 6 meters per second squared in the negative x direction. So remember, on a velocity versus time graph, acceleration is represented by slope. So this means a constant slope of negative 6 meters per second squared. And that's going to happen for the remaining time. So might look something like this. Now we need to figure out where this graph crosses the time axis, so at what time. And then once we have that, we can calculate the areas to determine the position of the body at time 11 seconds. So we'll call this 11 seconds. Okay, so we can determine when the object's velocity is 0, the time at which the object's velocity is 0, by using one of our equations. So we know right here that the velocity, the initial velocity, is 24 meters per second. We know the acceleration is negative 6 meters per second squared. We want to know at what time the velocity is 0 meters per second. So we can use this equation. Velocity equals initial velocity plus acceleration times time. We'll subtract initial velocity from both sides of the equation to leave us with velocity minus initial velocity equals acceleration times time. Divide both sides by acceleration to leave us with time equals final velocity, which we know to be 0 minus initial velocity, 24 meters per second, divided by acceleration, negative 6 meters per second squared. This is equal to 4 seconds. So 4 seconds from this point, the velocity is 0. So 4 seconds from 1 second is 5 seconds. And then we also need to know the speed at time, the velocity at time 11 seconds. Once we have that, we have everything we need to calculate the position. So in order to find this velocity, we're going to use the same equation. We'll say final velocity is equal to initial velocity from here, let's say, which can be 0 meters per second. Maybe I'll write out all the variables first. Initial velocity plus acceleration times time. So we know that the initial velocity at time 5 seconds is going to be 0 meters per second. Our acceleration will be negative 6 meters per second squared. And the time is 11 seconds minus 5 seconds, so 6 seconds. So this is going to be negative 36 meters per second. So that's this value here, negative 36. Okay, now we have everything we need to calculate the position of this body at time 11 seconds. So first, let's calculate the displacement of the object during this portion of its journey by finding the area here. So remember, on a velocity versus time graph, displacement is area under the curve. So this area is going to be 24 times 1, length times width, 24 meters per second times 1 second gives us 24 meters. So for this portion we have 24 meters. Now we want to find this area, which is triangular. So that area is 1/2 base times height, where the base is 4 seconds. So the difference between 5 seconds and 1 second is 4 seconds. And the height is 24 meters per second. So if you evaluate that using your calculator, it's the same as 4 times 12, which is 48 meters. So here we have 48 meters. And now we want to find this area. Again, it's triangular, so it'll be 1/2 base times height, which is 1/2 times 6 seconds times a height of -36 meters per second. And if you evaluate this using your calculator, you should find that it's equal to -108 meters. This area is -108 meters. Now if we add all of these up, we'll be able to find the total displacement from the initial position. So total displacement is 24 meters plus 48 meters minus 108 meters, which is equal to -36 meters. So if we consider that the object started at position x equals 0, then its final position is x equals -36 meters. So that's the answer to this problem.